Okay, here are 6 examples of this more difficult type of factoring. Notice they all have a coefficient out front, so that's going to indicate to you that they're going to require a little more thought to break this puzzle, crack this code. But let's just work through them. But as a reminder, as always, make sure that you're approaching these problems with the open mind that a greatest common factor could exist. In this first one, I don't see anything in common between 2, 25, and 12, or anything in terms of x, so this will jump right into unfoiling. And I kind of want to compare these two problems because they're very similar. They both have the same leading coefficient and the same constant term, albeit one's positive and one's negative. We can approach them with the same idea. All right, so this initial term, 2x squared, again, start off by asking yourself, where could that come from? So when this first number happens to be prime, there's only one option, right? That's a happy day for us. We don't have to think too hard. I know this has to start off with 2x and 1x. Same goes down here. All right, we go to this trailing constant term and we cycle through 3 and 4, 6 and 2, 12 and 1. All right, again, none of these add up to 25, so it's not really illuminating to just look at these pairs, and we're never going to come up with which pair I need to get to 25 if I just look here. So that's when I go to this setup that we've created, and I try to fit one of these 6 numbers back here. I always look back here because I always put my largest coefficient here. So what I mean by that is between 2 and 1. I'm going to always put my 2 out front, my largest coefficient of x I put out front, because then whatever I put in this back spot is going to be affecting my middle term the most. Okay. So we can see that. If I put a 3 back here, that'll be 2 times 3, that'll give me a 6x. That doesn't seem close enough to 25. If I would choose to put a 4 back here, that'd be 2 times 4, that'd be 8x. Not good enough. Okay. If I put a 6, 2 times 6 would be 12x, getting closer, but still probably not good enough to get up to your 25. So you can see how you don't have to make so many mistakes. Right? You can just kind of plan ahead. None of these seem to be working except maybe the 12. Notice if I put the 12 back here, right, 2 times 12, well, that's pretty close. That's 24x. And that's how I start these problems. It doesn't work every time. It's not 100% effective, but it is very effective to try to find which of these numbers can I place here that's going to get me as close as possible to this middle term. And you don't want it to equal the middle term exactly, but if I can get it as close as possible, I'm willing to bet 9 times out of 10, maybe just 8 times out of 10, that it's going to be the right pair. So if I put 12 back here, and 1 in the front, it's certainly a good place to start. Right? We'll learn something from this if we make a mistake, but I think this one's going to work out. Right, check our middle term. Again, we only need to check the middle term because we know 2x and x, that's 2x squared. I know 1 times 12, that's 12. This is my concern. The middle term comes from our outside and our inside pieces. So 2x times 12, that's 24x. 1 times x, that's 1x. And these two, if we added them up, could get us 25x. And if we found their difference, could get us 23x. Well, good news. 25x is where we're at. Let's make a little line here to break this up. Okay, so 25x is what we want, but we don't want positive 25x, we want negative 25x. So I'm going to go ahead and throw a negative in there and say, if I want negative 25x, what 2 signs would I need? And remember, this is that trick where if this is negative and this is positive, it will always be the same, where both of these have to be negative. Right? I don't really like to rely on that trick. I just convince myself, or just do a little bit of math. I know the only way for these two numbers to add up to negative 25 is for both of them to be negative. So then I go back in, put my 2 negative signs in, and we're good to go. Notice we didn't have to make 6 mistakes to figure out which one was the right way to go. Right? We used a little foresight, planning, and basic comprehension of what foiling foiling is to figure this out. All right, notice if this number in the middle, this middle term has a very large or a pretty large coefficient, this is just another hint or tip. All right, if this number is big compared to these other guys, well, then my thought, the only way for me to get a large middle term is for me to use a large factor. So 12 was my largest factor over here. So this middle term, although it's not the greatest helper, it gives you a little bit of a hint as to what pair you're going to use. All right, so look down here. I have the same beginning and ending, but a vastly different middle. Instead of having a huge middle term, I have a much smaller middle term. All right, the middle term isn't going to tell me exactly which pair I need to use, but it gives me a little hint into thinking that 12 and 1. 12 and 1 is probably not going to be my best bet, again, because if I place a 12 here, 12 times 2 is 24, which is way out of range of this middle term that I want. So I don't even think this is going to work. So again, as another helpful hint, and you'll gain these insights the more practice that you get. But if I want to make this middle term of 5x happen, this number is small and in between 2 and 12 and in this range. So I think 3 and 4, the smallest, closest together pair, is going to help me out. We just have to make sure we put it in the right place. So, which place am I going to need the 3 and the 4 to get close to 5? Right, here's where you might make a mistake. You might go here and you might say, I'm going to go with 3 and 4, and that would be a very good first spot. I'm not opposed to that at all, because you might be thinking 2 times 3. Well, that's very close to 5. That'll give me 2 times 3, that'll give me a 6x. All right, that's as close as 5 as you can get. Downside, this inside term does not help us out as much as we thought, 6x and 4x. These are not going to add up to 5. So right, that actually is not the correct way to put them in. So that was a very good first guess if that's what you tried. But that doesn't mean you should give up on it. Switch these around. Outside terms, we have 8x. All right, still pretty close to 5. And then on the inside, 3x. And now we can see 8 and 3 can group together to get us 5. How do we get 5? If we had a positive 8 and a negative 3. So I always like to put the signs in over here, or at least mentally do it. 8 minus 3 would give me 5, so let's go back to this problem. 2 times 4 is 8, so I need positive 8. And I would need this 3 to be negative. And there we have it, so that would work. And you can always double check these by foiling it out, because it's not as obvious as our previous section 6.3, but if you foil it out, it'll show you that it's correct. All right, let's work through these a little bit quicker. No common factor here. All right, this first term, 5x squared. Again, it's a nice start because I know 5 times 1 is my only possible way to get 5x squared. Go to our last piece. 3 times 2 and 6 times 1. Right. You might be tempted here to choose 6 and 1 because 6 plus 1 is 7. Right. Again, don't fall for that trap. It's most likely not the case or the pair that's going to work out, because it doesn't matter if these add up to 7. This 5 is affecting this problem dramatically. So if I put a 6 back here, that's not going to end up being a 6. That's going to end up being 5 times 6, a 30. So I don't even think 6 and 1 is a good choice, because all 3 of these numbers are close together. I think 3 and 2 is going to keep my numbers close together. So that's where I'm headed for this. Right. If we put these in the correct place, right, I think a 2 back here is the best option, because if I put it a 3, that'd be 3 times 5, 15. That seems a little too high, but 5 times 2, that gives me a middle term of 10x. That means a 3 would have to be here. Gives me an inside term of 3x. And there we have it. We can see the 10 and the 3 making the 7. We need negative 7 though, so these two signs would have to be negative 10 and positive 3. Go back into here. 5 times 2 is 10. I need that to be negative. And this 3 has to be positive. This guy. no common factor. Let's try to unfoil it. In this case, 4 is now kind of a trouble spot. 4 could be 2 times 2, or it could be 4 times 1. We do not know. Right? 6 can be 3 times 2 and 6 times 1. Again, we don't know. Right? It's kind of a crapshoot. If you start this off, you could say, I want to start off with 2x and 2x. Maybe you're right. You could be wrong. You could have the wrong starting point and try a whole bunch of options and have to go back to the beginning and say, well, maybe it's 4 times 1. Again, it doesn't have to be completely luck. Use this middle term to kind of help you out. And now that we know how to find this middle term and kind of see it before it happens, you can kind of pair these up at the beginning and see, well, if I pair this 4 up with 3, that would be 12. And if I pair the 1 up with the 2, that would be 2. I'd have 12 and 2. That's close. It's almost 11. That's pretty good, but not quite good enough. Right? What if I pair the 4 up with the 2? So try to pair the 4 up with every one of these and see which one's going to work out. And if you do that correctly, right, we're going to find out that 4x and x is actually the right option. Right? And 3 and 2 is the right option, and specifically in that order, because we put the 2 back here. Right? 4 times 2 will get us 8. That would mean a 3 would have to go in the beginning. That'd be 8x and 3x. And bingo, we've got 11 happening. Again, you're going to get better at this the more you try and the more you fiddle around with, right, which pair you want to put with each pair. But it's all little multiplication and little addition steps, and I think we can do that internally or mentally. And 2 more quick ones. This one, right, it's got some y's in it, but again, don't let that affect you. Right, it does not have a common factor between any of the terms. Right, but it does create more of a problem at the beginning because we have 3 times 4, 6 times 2, and 12 times 1 being an option. Right, I'm not going to give you a situation where you have a whole bunch of options because this becomes a very tedious and more difficult process that there's no real streamlined way to do when this number gets big. Right, but I will use the same strategy that we had before in trying to pick, right, which of these pairs do I want to use, which of these pairs do I want to use. This middle term can help you decide. Right, since this middle term is just a 7, which is small and relatively close to 12 and 12, I don't think using large numbers like 12 and 1 are going to help me keep my numbers small and close together. I think if numbers like 3 and 4 are going to help me do that. So I'm going to be partial, and just from experience, and because I made this problem, I guess that I'm going to start off with a 4x and a 3x. Right? But mostly from experience, honestly. This number is small, I'm going to keep my numbers small. Same goes for the back end. I think in order for this to work, I would need small, close together values. Okay? And it works out here. If we have 4 and 3, it might take you a couple guesses to find out the right place, but check this out. 4x times 4, that's a 16x. 3 times 3, that's a 9x. And eventually you start to see this happening without having to guess and check. You can pair these numbers up mentally and find this middle term. In order to get a positive 7, that'd be 16 minus 9. 4 times 4 is 16, positive. This one has to be negative. And this last one, I put this one in solely to remind you that you can't always jump straight into this unfoiling process. You do have to be conscious of a GCF. And this one, look, all of these are divisible by 5. So remember, if we can, this is going to make our life a lot easier. To GCF this problem, divide all of these by 5. We have 3x squared. 5 into 65 is 13x plus 4. And then this piece that's left over is going to be a much nicer polynomial to unfoil because this first coefficient's a 3. I've only got one option to multiply to get 3 instead of 15. That could be 5 times 3 or 15 times 1. That makes it more difficult. I want to deal with smaller numbers. we can break this apart into 3x and x. And hopefully by now we start to piece this together. This is 4 and 1 or 2 and 2. Well, I think a 4 back here is going to be great. 4 times 3 is 12. 1 in the middle. 12 and 1 add up to 13 if they're both positive, and we factored it. All right. So a little bit more difficult. You do have to think about more things. Right? There's more pieces to the puzzle, but once you see them interconnecting and click, I think it's a good feeling to solve each one of these little puzzles.